Hi, I'm Ron Green, and welcome to STC's presentation on FPGA-based prototyping. FPGA-based prototypes are indispensable tools for nearly every development effort, from computers and networking to robotics, automotive, communications, and more. How are these systems used? They can serve as vehicles for architecture exploration, making it easy to render and test competing designs. They are adept at verifying large system blocks, as well as testing block integrations. And in the role of software development platform, FPGA-based prototypes are the fastest executing systems available, next to silicon. So how can these prototyping systems tackle such diverse problems? The challenges faced are unprecedented. Designs of hundreds of millions of gates, approaching 1 billion, gigabytes of memory needed, performance in the megahertz. Groups such as architects, integrators, and programmers need different tools like simulation acceleration or a platform for verification. And in today's organizations, where teams may be dispersed across time zones, it becomes necessary to manage resources globally. To address these demands, a complete prototyping system is needed, one capable of handling designs of any size, at any design stage, and working across geographically dispersed areas. FPGA-based prototyping systems are uniquely suited to handle the needs of growing designs. They can easily expand by adding gate capacity and can add memory and subsystems to fit virtually any purpose. As designs move through various stages, engineers must tackle a range of tasks running from behavioral simulation to verifying interfaces and developing software and firmware. FPGA-based prototypes are a natural choice to address these issues and have been used for co-simulation and simulation acceleration, as well as serving as platforms for hardware validation and software development. And company-wide intranets now make it possible to share and allocate prototyping resources around the globe, making these systems extremely versatile across the entire organization. Despite these advantages, systems of the past were known for several limitations. Earlier generations of FPGAs were smaller, requiring designs to be partitioned across a large number of devices. With the tremendous capacity of the latest FPGAs, the partitioning task has become more of a grouping task, where even large designs can fit into just a few devices. Previous generations of FPGA prototypes were also known for limited capacity, but the latest systems can provide virtually unlimited capacity, easily scaling from 20 million gates to over 1 billion. Memory is also easy to provide and can be added on to total as much as 256 gigabytes. FPGA-based prototypes of the past were also known for being difficult to debug. Typically, signal traces were generated separately for each device, fragmenting the waveform view of the design. Signal names could be hard to recognize after processing through synthesis and FPGA place and route. However, with the addition of a dedicated module, trace information can be brought together and consolidated for a more natural view of signal activity, making debug much more straightforward. STC offers a unified line of platforms to fit nearly any design size or configuration. Logic module prototyping boards are available in single, dual, and quad FPGA configurations. Using either Vertex 7 or UltraScale devices, gate capacities range from 20 million gates up to 176 million gates on a single board. STC's line also includes systems built with Kintex FPGAs and Altera Stratix devices. STC offers the Prodigy Cloud Cube, a rugged platform uniquely designed to accommodate multiple board prototype configurations. It supports any combination of logic modules and supplies power and networking to all boards. Holding up to 8 quads, the Cube provides a secure environment for your prototyping hardware and can form the backbone of a network-enabled development resource. To simplify prototype development, STC provides an extensive library of prototype-ready IP, a collection of over 80 daughter cards, including functionality such as memory, processors, and multimedia to speed your prototype development. With all this hardware, you might be wondering about software. STC's suite of software tools is a key part of the product lineup, including Player Pro for prototype configuration and bring-up, ProtoBridge for interfacing your prototype to software running on a host, and Prodigy Neuro for networking and managing prototyping resources. These software engines can dramatically drive the productivity of your prototyping platform. The heart of S2C's productivity suite is Prodigy Player Pro, a tool that provides two distinct modules. The Compile module encapsulates synthesis and FPGA place and route software, and can partition a design across multiple devices and boards. Player Pro also includes a runtime module that connects to a running prototype. Runtime provides features such as the ability to dynamically specify clocks and resets, monitor voltages and temperatures, perform self-tests, remotely reconfigure with different designs, and more. ProtoBridge is a tool that provides high-performance, transaction-level communication between a hardware design and software models. Specifically designed to address the growing number of AXI4-based designs, ProtoBridge builds upon the existing prototyping flow, adding two key components: a PCIe to AXI bridge connecting to the user's design, and a matching C API library and device driver running on an attached host. Communicating over the PCIe interface, ProtoBridge enables software control over the hardware. Programs can directly read and write to the hardware, transferring large amounts of data at high speed. The ProtoBridge C API library also enables integration with various commercial tools. Shown here is a configuration that integrates with Mentor Graphics Vista Simulator. Integration with Vista creates a complete System C transaction-level based virtual prototyping platform. Coming soon from S2C is Prodigy Neuro, software that manages prototyping resources at the global level. Neuro will provide for high-level system administration, control of resource allocation, and monitoring of system parameters and usage. This brings together all the elements needed to realize a complete prototyping platform. S2C's family of logic modules in single, dual, and quad configurations to accommodate designs of any size. A library of prototype-ready IP provided as a family of daughter cards that can easily extend and adapt your prototype as needed. The debug module that eases the task of debugging designs partitioned among multiple FPGAs. Prodigy Cloud Cube, a secure environment for multi-board prototypes and a framework for providing a network of resources. Player Pro, for building and controlling your prototype. ProtoBridge, to connect and drive your design with test and application software. And Prodigy Neuro, for controlling and managing your enterprise of prototyping resources. This is the complete prototyping platform from S2C, one of the most comprehensive, flexible, and high-performance systems available today. Thank you very much for your interest in our product line, and from everyone here at S2C, we wish you speedy success with all your prototyping projects.